the budget constraint indicates the different purchasing options that the consumer has. So given a certain budget and prices that the consumer faces, what are the different combinations of quantities of two given goods that he has the option of purchasing? In particular, the budget constraint tells us the combination that he can buy if the full budget is spent. And so we'll show that in an x1, x2 graph. And you could already see how if we're trying to find the intersection with the x1 axis, well, this corresponds to a 0 value for x2. And so the amount that can be purchased at most of good 1 will simply be the full budget divided by the price of good 1. If, on the other hand, the consumer doesn't purchase any of good 1, then he can put the full budget towards purchases of good 2. And so the other extreme of the budget constraint will be at m over p2. Everywhere in between, the rate at which he exchanges good 2 for good 1, or good 1 for good 2 going in this direction, is constant because prices are constant. And so we should expect the budget line to be a straight line. Okay. Now, the slope of the budget constraint is an important one. And we could see that one way to calculate it will be to divide the rise, m over p2, by the run, m over p1. And this will allow us to obtain the absolute value for slope as p1 over p2. Okay, so the slope of the budget constraint equals the ratio of prices. There's an intuitive way of looking at this as well. So for example, if you pick some point on the budget constraint and draw a horizontal line, then the slope of the budget constraint can be seen here as well as here. And here's one way to derive it. Imagine that you purchase one less unit of good 1. Well, that frees up P1 dollars. Okay, with P1 dollars, you can purchase P1 over P2 units of good 2. So if this is 1, this will be P1 over P2. Okay, so it's the number of units of good 2 you can buy if you buy one less unit of good 1. Equivalently, we could look at it in the other direction. Suppose you want to buy one more unit of good 1, you can need P1 dollars. For that, you need to sell P1 over P2 units of good 2. Okay, so another way to think of the slope of the budget constraint, that it is the number of units of good 2 that you could purchase, that you have to give up in order to buy one more unit of good 1. And so either way, you can see how the slope is essentially a measure of the value in the market of good 1 in units of good 2. We could also write the budget constraint algebraically simply as x1 p1. So the money spent on good 1 plus x2 p2 equals m. Okay, so the amount of money spent on good 1 plus the amount of money spent on good 2 equals the total budget m. Okay, and that equation describes this line as well. Let's consider the following example where you have $240 you could spend on movies, which cost $30 each, or video games, which cost $60 each. Then the budget constraint is the one shown by this line, which shows that you could purchase at most 4 video games or at most 8 movies. In between, the trade-off rate is 1 to 2. So every time you buy one less video game, that allows you to buy 2 more movies. Okay? And so the slope is 1/2, reflecting the fact that a movie is worth half a video game. Now let's consider some possible changes to parameters. First, what will happen if there's an increase in the budget to $300? Now you could afford at most 5 video games or at most 10 movies. In between them, the trade-off rate will remain the same. Every time you buy 1 less video game, you could buy 2 more movies, and so on. So the new budget constraint will have the same slope as before, but both intercepts are moving out by the same proportion. This represents an increase in purchasing power because you could see that all of those baskets in that swath are newly available options for the consumer. What if the price of good 1 changes? Suppose, for example, that movies become more expensive and they now cost $60 each as well. Now, this intercept will shift in because we could afford at most 4 movies. The trade-off rate will be 1-to-1 because prices are the same. So every time you buy 1 less video game, you could buy 1 more movie, and the other way around. Okay? Now this represents a decrease in the consumer's purchasing power. The budget constraint pivoted in, so there's a number of baskets that the consumer can't afford anymore. Generally, whenever there's a change in the price of good 1, the budget constraint will pivot around the intersection with the opposite axis. What if instead we have a change in the price of good 2? Suppose that video games went on sale for 50% off. Now we could afford at most 8 of them. So this intercept would shift up. This intercept would not change. Instead, the slope is changing. Okay, and so in general, when there's a change in the price of good 2, the budget constraint will pivot around the intersection with the opposite axis.